Our question is, ethylene glycol CH2OH CH2OH is a common automobile antifreeze. Calculate the freezing point of a solution containing 651 grams of the substance in 2,505 grams of water. So first thing we have to figure out is, what is it asking for? The question is asking us to figure out the freezing point depression of the water caused by our EG, our ethylene glycol. So the equation we are going to be using to figure out this is delta T F. It's a change in the freezing point, and it's equal to Kf, a constant given to us over here, Kf 1.86, times the molality of the solution. So in order to figure out molality, it's defined as the moles of solute over our mass of solvent. But you gotta watch out because this guy is in kilograms. So first thing we gotta do is figure out how many moles of solute we have. So this is our solute, ethylene glycol, this good boy right here. We got 651 grams of him. So we have to figure out just how many grams are in 1 mole. And you do that by adding these guys up on the periodic table, and you'll get 651 grams of ethylene glycol is equal to, we have 1 mole, 62.07 grams ethylene glycol. And that's going to end up giving us 10.5 moles of this guy. Okay, so now that we have this, now we have to figure out our mass of solvent in kilograms. That's an easy one because we have 2,005 grams of water. That's going to easily translate over to 2.505 kilograms of H2O. So now we have both of our mass of our solvent and our moles of solute. All we have to do is divide. So we're going to have 10.5 moles of ethylene glycol over our 2.505 kilograms of water. Divide this guy up, plug him in the calculator. It's going to give us 4.19 molality. Alright, so now that we have our molality, all that's left to do is plug it into the equation with our K. So we're going to have delta Tf, freezing point depression, it's going to be 1.86 Celsius, just get units in there, times our 4.19 molality. Multiply those guys, and it's going to give you, freezing point depression is 7.79 degrees Celsius. Now you might tell yourself, oh, we're done, but not quite. So our normal freezing temperature of water is 0 degrees Celsius, right? So in order to figure out how much this is going to change, all we have to do is take our answer and subtract that from the normal freezing point of water. Pretty straightforward, and it's going to give us negative 7.79 degrees Celsius. And that is going to be the new freezing point of our solution.